So this is the question. They are saying that uh, please concentrate here. A copper wire of length 1 meter and radius 1 mm is joined in series with an iron wire of length 2 meter and radius this, and a current is passed through the wire. The ratio of current densities in the copper and the iron wire. So they are saying we are having two wires. This is one wire. One wire is this, and another wire is this, and they are connected in series. They are connected in series, and series connection is like this, and a current is flowing. In series connection, the current is same. In both the wires, the current will be same. So suppose the I current is flowing in this wire, and in this wire also the I current is flowing. And length given of, suppose this is a wire of copper. This is a wire of copper, and length is given as 1 meter. And the length of this wire is given as how much?
It's 2 meters.
Yeah. 2 meter length given. And the name of the wire in
iron. The length of the wire is 1 millimeter, sir, not 1.
Oh no, this is meter.
Oh yeah, sorry. The radius is 1 meter.
Radius is 1 meter. So iron wire have the length of 2 meter.
Yes, sir.
So radius of copper wire is 1 meter, means I am saying radius means this distance.
Yes, sir.
This is given as, I am supposing this as R1, and this is 1 mm. And radius of this wire, the dimension of these wires are looking same, but the dimensions are not same. So radius is given as 3 mm. 3 mm radius. So R1 is 1 mm and R2 is 3 mm. So they are asking the ratio of the current densities. Current densities means J1 of this, and I am supposing the current density. Current density is represented by J.
Yes, sir.
Supposing the current density is J2 of. So current density J1 is equal to I1 divided by A1. For J2 you will write I2 divided by A2. J1.
Yes,
what
sir.
is I1? I1 is I. And area of cross section you will take this area. This is pi r square.
Yes, sir. Pi r square. Sir.
Pi and
pi
r
square
means R1 square. You will do the square of 1, means 1 square. So this is J1. Similarly, J2 when you will calculate, you will get I divided by A2. A2 means pi and the radius square means 3 square. Now they are asking J1 divided by J2, ratio of J1 by J2 they are asking. So you will get I divided by pi 1 square multiply. When you will divide this, you will get this into the numerator, sorry, 3 square divided by I. This I cancel out, this pi and this pi is cancel out. You will get 9:1. So the ratio of the current densities is 9:1. So answer will be this. I'm solving the second question.
Second is called for 1 minute.
Oh, I will give you the time after
No,
this.
sir, I'm on the last line, sir. Done, sir.
So next question is, they are saying a conducting wire of cross section area. We have a conducting wire, and they are saying the cross section area is given as 1 centimeter square and has this in charge carriers, means number of conducting wire is there. So in a conductor we have the free
Yes, sir.
electrons. So charge carriers are the free electrons in a conductor. So we will have n, small n is given. Number of electron per unit volume is given as this, meter to the power minus 3. Meter, the unit of volume, free electron per unit volume is this. So if the wire carries a current, and in this wire the current is flowing as I and given as 24 milliampere. Okay. So we have to find the drift speed. We have the formula of drift speed. I is equal to A
I
and
A N E
VD. V means with drift speed. Okay. So I is given as 24 milliampere. You will convert it into 10 to the power minus 3. Area is given as 1 centimeter square. This will become 10 to the power minus 4. N is given as 3 into 10 to the power 23. Charge on electron is 1.6 into 10 to the power minus 19, and VD we have to find. Now we can solve this this thing and this. First calculate all the powers. Resultant of this is minus 4. This is minus 19. So this will become minus 23. This will become 10 to the power of minus 23. And we have already 10 to the power 23 and into 1.6. When you will multiply this with this, you will get 4.8. And this is VD. And here we have 24 into 10 to the power minus 3. This term and this term will cancel out. And you have a drift velocity of 24 into 10 to the power minus 3. And this will become 4.8. Okay. Now, when you will solve this, you will get, when you will remove this point, you will get here 240. 48 into 10 to the power minus 3. Now you can cancel this with the 12. 4 is a 20. Then you will get 4 5s are means 5 into 10 to the power minus 3 meter per second. You will have the drift speed. So this is the answer. 5 into 10 to the power minus 3 means this option is correct. B option is correct. Please note it down.
Yes, sir.
I have just applied this formula only with the help of this formula. And remember one thing, you will put all the values in the SI unit.
Yes, sir. Yes.
I have converted this centimeter square into meter square. I have converted this milliampere into ampere.
Ampere. Done, sir.
So we were discussing this superconductor we have completed.
Yes, sir.
And now we will study a relation between the resistance and temperature. So write the heading. Quantitative relation between the resistance and temperature. The relation between the resistance and temperature. So the derivation of this is not the part of your syllabus, so I'm just writing the formula only. So writing the formula. So this is the formula. R suffix T is equal to R naught 1 plus alpha T minus T naught. And RT is the resistance at temperature T. Resistance at temperature T. R naught is the reference temperature. R naught is the reference temperature. And you will take reference temperature as either 0 degree centigrade or room temperature. Or room temperature. Now, T is the temperature at which you want to find the resistance. T is the temperature at which you want to find the resistance, and alpha is the temperature coefficient of resistance. Temperature coefficient of resistance. And this temperature coefficient of resistance is depending upon the material. If you will change the material, suppose if you have a copper, then the value of alpha is different. Suppose if you have a semiconductor like germanium and silicon, then the value of alpha will be different. So this will depend. This will depend. Depends on, you can say, on material. So this is the formula. In the numerical, you can use this formula. Derivation is not the part of your syllabus. So there can be the numericals. They can give this data and ask any one of the data, like they can ask temperature or resistance accordingly. So for conductors, if you will take alpha, then alpha for conductor is positive. The value of alpha is positive and large. Large value. For alloys, you will take alpha, and alpha will be positive but small value. And if I am taking semiconductor, or insulators, you will take alpha, then you will get the negative value of alpha. So I am just giving you one example how with temperature change the resistance will change.
Okay, sir.
Initially the temperature is 10 degrees centigrade, 10 degrees Celsius or centigrade, and we have a copper material of copper means copper wire and having a resistance of 10 ohm at 10 degrees centigrade, and we have a gold foil, or you can say material of a gold, and having the resistance 10 ohm. At 10 degrees centigrade, copper and gold both have 10 ohm and 10 ohm resistance respectively. When you increase the temperature to 30 degrees centigrade, then the resistance will become 12 ohm and resistance of gold will become 15 ohm. So in this way, the resistance will change accordingly. For different material, the change in the resistance will be different.
Yes, sir.
So see here, you have increased the same amount of temperature for copper and gold, but you are getting different change in the resistance. Uh, Here the for copper the resistance remains 10 ohm. No, sorry, for copper you will get 12 ohm resistance after increasing the 20 degree centigrade in temperature, and for gold you are getting only or you are getting 5 means 15 ohm difference of 5 ohm. So note it down.
Yes, sir. Sir, you can scroll down, sir.
Okay.
Yeah, that's it.
Now we will discuss the circuit analysis, series and parallel combination.
Done, sir.
So write the heading circuit analysis. In the circuit analysis, first we will study the series and parallel combination of resistors. Secondly, we will study series and parallel combination of cells.
Okay.
Thirdly, we will study series and parallel combination of bulbs. Fourth, we will study Chop's law. Yeah. So earlier we have discussed the series and parallel combination of capacitors. But this
Yes,
time we
sir.
will study the series and parallel combination of resistors, cells, bulbs, etc. So please note it down first.
Done, sir.
So now, before discussing the series and the parallel combination of the resistors, I will tell you how in a circuit the current or the voltage divides. So first, we will study division of current in division of current. The condition for dividing the current is current divides due to branching. Due to branching. Now, see here. If you have a wire this and resistances are connected like this, Harsh, this is a symbol of resistance. Resistance means the hindrance in the path, and this is looking like the hindrance in the path. This path is smooth. This is the hindrance in the path. So that is why we represent
Yes, sir.
the resistance like this. So if the wire is same, there is no branching, then the current will remain same. Current will remain same. I current, if you are having resistance R1, R2, R3, R4. Now, if you have resistance connected like this, so the wire is same, there is no branching in the wire. So here also the current will same in this wire. In this wire also the current will same because there are no branching in this wire.
Yes, sir.
Current is same. Now I am just changing little bit. Suppose this resistor is connected like this and this wire is connected like this. With the resistance, suppose this is a resistance R1, this is R2, R3 and R4, and the current is flowing in this resistance is I current is flowing from here to here, means in this wire the current across R1 will be I, but
I,
this is the junction point, and from this
it will be
junction,
I1, I2,
yeah, from this junction point the current is dividing. Current will divide as the wire is changing from here now.
Yes, sir.
Here the wire is changing. I am just giving the example. This is the wire, and in this wire, from here to here, you will take the current will remain same. If you bend this wire like this, then also the current will same. Whenever
Yes.
when you will make the branches of this wire, means connect this wire with some another wire, then the current will divides accordingly. So if I current, suppose I am supposing the I1 current going in this wire, and I2 current going here, and I3 is going here. I3 is going here now. This is the value of resistance R3. Don't compare this with I2 and R3. Okay, so you can write I as I1, because this I is dividing now
Yes, sir.
amongst this resistance. So I can write
Yes, sir.
I1 plus.
I1 plus I2 plus I3.
Yeah, very good. Okay. Now that's how the current will divide in the circuit. Now the division of voltage you will see. Division of voltage. The condition of dividing the voltage. Okay. So voltage divides when you connect the wire with some resistances or some capacitors or bulbs or any other device when you will connect. So if you have a wire like this, now this is point A, this is point B. I am just taking the points. This is point C, this is point D, this is point E, and this is point. Take this point as M. A, M, B, C. We have these points on the wire. So here the voltage is VA. Again here also the voltage is VA, because there is no hindrance in the path. Now when you will cross this, there will be some voltage drop across this resistor. So here will be the voltage VV. Here when you will cross again this, here the potential, not the voltage, this is the potential at point A.
Yes, sir. It will be
Here,
VD.
yeah, actually earlier also in case of capacitor I have told this thing. Here is VD, here also the voltage is VD. So means when you will moving like this, and in the path if there is a resistance, then the voltage will, then the potential will change. So you can write it. And if you have a wire like this, single wire and no resistances are connected, this is point A, if this is B, C, D, E, then voltage at A is VA, voltage at V if is VV, VC, VD, VE. then VA is equal to VV is equal to VC is equal to VD is equal to VE. Why these voltages are equal? Because when you are moving from A to E, there is no resistances in the. Why these potential at all the points are same? Because when you are moving from A to E, there is no resistances. There are no resistances in the path. That is
Yes,
why
sir.
all the potential are same.
Yes, sir.
So you can write one more thing here. Now, one thing more I want to write. If you have a wire like this, now there are, this is the wire and branching are there. This is the wire like this. This is point, at this point is voltage is VA, VB, VC, VD, VE, F, G, H, I. Will all the voltages will be same or different? Harsh, what will you say?
It will be different, sir.
Why?
So there is branching, sir.
No, branching is valid only for current.
Oh, sorry. Not branching, but how do I
All
write
the
it? Yes, sir.
actually
Yes, sir.
all the voltages are same because I have told you
Oh, yeah,
when
there
you
is no resistors.
yeah, there are no resistance. See, there is no
Yeah, sorry.
resistance. There is no resistance, and I am taking a wire having the resistance 0.
Yes,
I am
sir.
taking ideal wire. Ideal wire means the resistance of the wire is equal to 0.
Yes,
Otherwise,
sir.
we know that the wires have the resistance in practical life. So you will say here potential at point A, potential at point B, potential at point C, potential at point D, potential at point E, potential at point F, potential at point G, potential at point H, potential at point I. All the points will have the same potential because in this wiring, no resistances are connected. Here resistances are connected. That is why you can say VA is not equal to VB and VB is not equal to VC and VC is not equal to VD, but VD is equal to VE. VD is equal to VE because when you are moving from here to here, there is no resistance in the path.
Yes, sir.
One more case I will take. Suppose if you have a wire like this. And Harsh, you have this point as A, this point as B, this point as C, this point as D,
Yes, sir.
this point at. Now, what you will say about the current in this wire? Will the current and one thing more. This resistance is R1, this is R2, R3. 4 resistances are connected like this. What you will say about the current across R1, R2, R3, and R4? You can check here also.
Yes, sir.
You can check here also. I have told you about the current. See this?
Yes. Current will be the same, sir.
Oh, very good. Current is same because why?
Yeah,
Because wire is same.
wiring. Yes,
Wire
sir.
is same.
There's no branching.
Yeah, very good. There is no branching means current here will be I. Here also the current will is I. Means in the whole wire the current will remain same.
Yes, sir.
But if I am asking about the potential at A, potential at A means VA, VV,
Yes, sir.
VC. Here is
VD,
potential VD,
VI, VD,
VE.
VE.
And now move from A to V. You are moving from point A to V. In between there is a resistance, so
Yes,
VA
sir. Potential
not
is
equal
different.
to, yeah, VA
Yes,
not
sir.
equal to VV. So VA minus VV is equal to the potential difference of voltage across R1 voltage, or you can say potential difference across R1, and I am representing it with V1. So V1 is equal to VA minus VV. For V2, what you will say? Means for V2, you will means the voltage across R2. You will subtract
Yes,
VV
sir.
minus VC.
VB minus VC.
Yeah. Tell me V3.
V3, VC minus VD.
Very good. And V4.
VD minus V.
VD minus V. And Harsh, if I am giving you a wire like this, and
Yes,
this
sir.
is point A and this is point B, I want to find VA minus VB. So what is the value of VA minus VB?
VA minus VB.
This is a simple wire and no resistance is connected.
Sir, it will be V, right?
No,
No.
V.
No, it.
Think. You can think. Actually, this is a single wire, and we know that, na.
No resistors.
I have told you when
Sir,
we have wire like this, all
yes.
the potentials are same. Means VA is
Yes,
equal
sir.
to VV. Here
So it will be
VA.
zero.
Yeah, very good. VA is equal to VV. VA is equal to VV, man, means this will become zero.
Yes, sir.
Now, please remember all these points. We will use all these points in.
Yes.
Now you can note all the points. So current is basically divided due to the branching, and the voltage divides when there are the
Resistors.
resistances,
Yes.
capacitance, or the capacitors in the path.
Yes, sir.
Harsh, have you noted down?
Yes, sir. Yes, sir.
Okay.
Like
This
not all
completed.
of it, but I did for current. Current divides.
This current, na? This
Yeah,
completed.
yeah, sir. Yeah, no, no. Yeah, yeah. This have to write, sir. Just a minute.
Okay. Completed, Harsh?
Yes, sir. You can scroll down, sir.
Okay, you can ask now.
Sir, can you scroll a little bit up where the voltage starts? That's it. Thank you, sir.
Hmm.
So, can you scroll a little bit down?
Completed, Harsh?
So, just a minute, sir.
So after this, I will tell you about the power loss.
Yes.
How the power lost when current flows through the resistance.
Yes, sir.
We will discuss the formula, and after that, we will discuss the series combination of resistors.
Okay, sir.
Yeah. But you should remember all these things.
Yes, sir. Yes.
Current divides due to branching.
Branching. Yes, sir.
And voltage divides due to resistance.
To resistors or capacitors or
Yeah, or capacitor in the path. So now
yes, done, sir.
I am telling you some basics. Suppose you have a resistance like this. You have a resistance like this, and this is the wire. A part I am taking, okay, a part of the wire I am taking, and I current is flowing in this wire. As the wire is same, the current will remain same. So suppose this resistance is R, and you want to calculate the power dissipated, power dissipated, power dissipated in R. Means now, so what is the logic of this? This is the wire. See, this is the wire, and current is flowing in this wire. I am saying current is flowing, so means flowing. So what is happening when the current flows? What is the current? Current is the flow of charge. Are you getting? Harsh?
Yes, sir. Yes, sir. Sorry, my mic was muted.
Okay. So current is a flow of charge carrier, and in the drift velocity we have seen in a conductor we have electron as a charge carrier, and these
Yes.
electrons collided with the ions. When the current flows, the electron collided with the ion, and this, due to this collision, there is a change in the momentum, and due to the change in the momentum, and some energy is lost in the form of heat. Some energy is lost in the form of heat, and energy loss per unit time is known as power. So we have the
Yes.
formula for the power. Power dissipated is the energy loss or heat loss per
In the
unit
form of
time.
heat. Yes, sir.
Power loss in resistance R, I am just representing this with capital P. So power loss is basically power dissipated. Very easy, yeah. Power dissipated is equal to heat energy. Your laptop is heating or not right now?
Yes, sir. Yes, sir. It is.
The heating is due to there is a wiring and
Yes.
current is flowing. Collision of electron is happening with the ions. That is why the heat energy is okay. And that heat energy you will take per unit time is the power, and formula for calculating the power loss or power dissipated is square of current and resistance. If you want to calculate the power lost through this resistance, then you will use this formula, or we have one more formula, V square by R, means potential difference across this resistance, square of potential difference across this resistance divided by the resistance, and either you will use this formula, potential difference and the current. So now we will discuss the series combination of the resistance, series combination.
Okay, sir.
I will give you the time for making notes. Okay. So
Yes, sir.
series combination we will discuss. Series combination of resistance, resistors you can say. So series combination is like this. When you connect the resistances like this, I am just connecting the 3 resistances only, but you can connect 5 resistances, 6 resistances, depending upon the situation. and these three resistances are connected like this, and this is the battery of voltage V,
Yes, sir.
and I am supposing this resistance as R1, R2 and R3. I have told you if the wire is same, the current will same.
Yes, sir. Current is sir.
So see, there is no branching here.
Yes, sir.
So current will same. Current will same, but current will same. But when you move from here to here, there will be a change of potential. Means the
potential.
Here the potential difference or the voltage is V1 across this V2 across this V3.
V3.
So what is happening? This voltage of the battery is divided among these three resistances. So you can write V is equal to V1 plus V2 plus V3. These resistance, this voltage is divided across R1 and R2 and R3. So you can write this now.
Yes, sir.
So now I am just doing one thing. I am making the instead of these three resistances, I am taking one equivalent resistance and connecting it with a same battery V. Connecting it with a same battery V, and now and current is flowing I. Current I is flowing. So from here you can calculate V is equal to IR.
Yes, sir.
R equivalent. V is equal to R equivalent. You will have from here. So here you can write instead of V, I into R equivalent, and V1 is equal to I1 into R1. V2 is equal to, for V2 you will write I2 into R2.
I2 into R2 plus I3 into R3.
I3 into R3, and
yes, sir.
We know that I1, I2, I3 all are same.
Yes, sir. So it will come out.
Yeah. I1, I2, I3 all are same, and that is equal to
I.
That is equal to
so
I.
It will be so it will be R1 plus R2 plus R3.
Yeah.
At the box.
I1 I can write I
into
R1. Yeah. For this I can write I into R2. For this I can write I into R3. Now take I common.
Yes, sir. It will be I into R1 plus R2 plus R3.
Yeah. So I and I cancel out. So equivalent resistance you will get R1 plus R2 plus R3. If you have connected 3 resistance, then you will calculate like this. If you have connected 5 resistance, then you will calculate R1, R2, R3, R4, R5. Addition of all. Got it, Harsh?
Yes, sir. Yes, sir.
Note it down now.
Yes, sir. So can I scroll down a little bit?
Scroll down, na?
Yes, sir. Down. That's it. That's it.
This?
Yeah, the formula after it.
You can write.
So you can scroll down. Done, sir.
Now, Harsh, we will just calculate some basic terms.
Sir, just a minute. So there's some problem with that. Just a minute.
Okay. Completed? Hello, Harsh. What are you doing, Harsh?
So there is no,
What is
it's
the
fine, sir.
what, is
Sir,
there any
actually,
problem?
my curse. Yeah, there was some problem. Actually, it
What?
kind of hanged the laptop.
Okay. You can restart it if you want.
No, sir, no, it's fine. It's fine. You can continue.
Okay. Now we will calculate some basic terms. Now we will calculate some basic terms. And now take this. So we will do all the things according to this circuit only.
Okay, sir.
I'm just taking this from here. I'm just okay. We can just continue with the above circuit also. So if I want to calculate the total voltage, and I will represent total voltage with V suffix T. Okay, V suffix T. So Harsh, please tell me what is the
Yes,
total
sir.
voltage here?
Total voltage.
Yeah.
Sir, it's V, right? No,
Yeah.
it's V1 plus V2 plus V3. Yeah.
V1 you can say V1 plus V2 plus V3, but that is all equal to with
It's
V.
V. It's V. Yeah.
So you can say either V1 plus V2 plus V3, or you can say total voltage is equal to V.
Yes, sir.
Second thing, total current. See Harsh, this is very easy things.
Yes, sir.
And you have to just apply the formula and
Yes, sir.
observe the circuit. Total current, how you will calculate the total current? This is the total current.
Yes, sir. It will be I, right?
It will be I, and how you will calculate the total current? I is equal to V divided by R equivalent.
Yes, sir. I will like I1.
No, that is fine. I is equal to I1 plus I2 plus I3.
Yeah.
But you can write I as, according to this, now you can write I is equal to V divided by R equivalent.
Yes, sir. Yes, sir. V divided by R equivalent.
Third part, current through each resistor. Harsh, see here.
Yes, sir.
Can you tell me what will be the current through each resistor?
Current. It will be I, right?
Yeah, of course. Very good. Means current through resistor 1 is I1.
Yes, sir.
You can write this. Fourth point, voltage across each resistor. Voltage across each resistor. Now Harsh, tell me what will be the
Sir.
voltage across each resistor. See here,
Sir, it
voltage.
will be R equivalent divided by current.
No, I am just asking voltage across resistor R1.
V1.
V1 na?
Okay. Yes, sir.
How you will write V1? V1 you will write I1 into R1,
Yes, sir.
and I1 here I1 is equal to I,
Yes.
and R1 we have. So you can write accordingly. You can write V2. V2 is equal to IR2. V3 is equal to IR3.
IR3.
Can I write like
Yes.
this? Very easy, na?
Yes, sir. Yes.
Now fifth part is power dissipation. Power dissipation you can calculate now. If you want to calculate the power dissipation across resistor 1, then you will write I1 square into R1, P2, I2 square into R2, P3, I2 square into R3. If you want to calculate the total power, then you can add all the powers, P1 plus P2 plus P3. So what is value of P1? And you can write this, current is same, so you can write this I square R. This also you can write I square R. This also you can write I square R, but this is R1, this is R2, this is R3. So here you will take I common, and R1 plus R2 plus R3, and total power you can calculate by I into R equivalent. This is R equivalent. Okay. Have you got this point or not?
Yes, sir. Got it.
I have told you this because of this. I have told you earlier this, na. If you want to calculate the power dissipation across a resistor, then you will use this formula. Either this formula, and I have used this formula. So now all the things are clear.
Yes,
Now you can
clear. Yes.
just copy it. This have you have completed this?
Yes, sir. Yes.
This?
Yes, sir.
All
the last
points?
point, sir. Yeah. Done, sir. Sir, I think I'm muted, sir.
What are you saying, Harsh?
No, sir, I think you were muted. I couldn't hear you.
Yeah, actually, actually, I have muted, but I am not speaking also.
I'm so sorry, sir.
I am just writing the question, and after that, I will tell you.
No, I thought you were speaking and then writing.
Okay. Every time I speak and write, eh?
Yes.
But this time, no requirement of. So you can just total voltage you have to calculate, and total current you have to calculate. All the things same.
Yes, sir. Okay.
You have to calculate uh, total voltage and voltage across
Across. Okay.
each resistor.
Yes, sir.
And total current and current across or through each resistor. Okay, Ash?
Yes, sir.
And for last point is you have to calculate power dissipated across each resistor. Power dissipated across each resistor and total power dissipated in the circuit. Can you solve this question, Harsh?
Yes, yes, sir.
By
Yes.
yourself?
Yes,
Just
sir.
try, and I am giving you a time of 5 to 6 minutes.
Okay.
Try yourself, and you can total power dissipated in the circuit, and you can check all things and formulas from here. Okay.
Yes, sir. Can you just show me the question?
Please note down the question first, and after that give it
Yes, sir.
one try only.
Yes, sir. The first answer is 15.
Okay, no problem. Don't tell me the answer. You can check your answer when you calculated all the parts. Okay,
Okay, sir.
you can check your answer. Okay, start, and I am giving you 5 minutes.
Okay, sir.
You can take 6 minutes also, but
Sir, done, sir. Sir, done.
Okay, I am just
Hmm.
solving all the parts.
Yes, sir.
You can check your answer. Very good.
The
Now
first one, R equivalent will be R1 plus R2 is equal to
okay.
15.
I know you have completed R equivalent when you will calculate. This is the series combination
Yes, sir. It will be R1 plus
R2 and
Yes.
R1 is given as 5.
5,
This is
10, 15. Yes, sir.
In the second part, total voltage.
Yes, sir.
Total voltage is given is 100 volt.
Yes, sir. 100 volt.
Very good. And they are asking V1, V2, V3. V1, V2, V3. So V1 is equal to I1, R1.
Yes, sir. I1, R1.
This is I2, R2.
I3,
This
R3.
is I3, R3, and I is same as this is a series combination.
Yeah.
So for this, first we have to calculate the I. For this, we have to just calculate the I, means third part.
Yes.
We have to calculate first. So if you want to calculate I, you will write V total divided by R equivalent.
Equivalent. Yes.
Yeah, V total is 100, R
100 by
equivalent is
15.
15. Then you will
Yeah.
get
It
10
is
by
6.66, sir.
Okay, that is fine. I am just writing in this form. Ampere. That your answer is correct and my answer is also correct.
So it will be 20 by 3, right?
No.
Wait.
See, 5, 3 is a 50.
Yeah.
Oh, you are right. 5 2s are very
And
good.
then 20, right?
Very good, Arch. 20 by 3.
Yes, it will be 6.66.
Yeah. So I, what is the value of I now? 20 by 3.
Yes, sir.
And multiply it with R1. And there is no R3, na? There is no R3.
Yeah, it will be 20 by 3 into 5.
Yeah. There is no R3, so into 5, this will become 100 divided by 3 volts.
Yes, sir.
This will become 20 by 3 into 10.
Yes, sir.
This will become 200 divided by 3
volts.
I we have already calculated, and we have to calculate I1,
I2, and
I2,
I3.
and all I1, I2, I3 are same.
Yes, sir.
Because this is
20
the
by 3.
Yeah.
Because no branching.
Yeah, no branching. Very, very, very easy question. And we have calculated. Now we have to calculate the power dissipated. Power. So P1 is the power dissipated in resistance 1.
Yes, sir.
What is the value of I1, Harsh?
I1 is 20 by 3.
Yeah. Square of this.
Yes, sir.
And R1 is 5.
5.
So square of 20 is 400.
400.
Square of 3 is
by
9.
Into 5.
So you will get
2000 by 9.
2000 divided by 9, and this unit of power is SI unit of power is watt or joule per second.
Yes, sir.
Because power is energy per unit time. So unit of energy is joule and unit of time is second. SI unit I am talking about.
Yes,
so sir. P2, now you tell me what is P2.
P2. I2 square by into R2.
Next.
It will be 20 by 3 whole square into 10.
Yeah.
Yes, sir. It will be 4,000 by 9. 4,000 by 9. Yeah.
Same
What?
answer. Your answer is also same.
Yes, sir.
Very good. And if you want to calculate the total power, so you can just add.
Yes, sir. We can add.
Power is a scalar quantity. We can add directly like numbers. 2000 by 9 plus 4000 by 9. So how you will solve this, Harsh?
Sir, it will be 6,000 by 9, right? Because
Very good.
LCM is same.
Yeah. 9 and unit is what?
What?
And I
Yes,
have
sir.
told you one more method to calculate the total power. Take the I square into R equivalent. I square we have 20 by 3.
Yeah.
And R equivalent
Yeah.
we have 20 by 3.
Yes, sir.
Answer is just wait. R equivalent is we have R equivalent we have 15. 15 na R equivalent. See, R equivalent we have 15.
Yes, sir.
So I will write here 15. So now this will become 400 by 9 multiplied by 15. This will become 6000 divided by 9 watts. See, the answer is same from both the methods.
Yes, sir.
Now, if you want to note it down, then you can.
Done, sir. Done. I already wrote it.
Very good.
I already finished it.
So this is the series combination. Now we will discuss the parallel combination, how the circuit is connected in the parallel combination, not the circuit, how the resistances are connected in parallel combination.
Yes, sir. Sir,
Yeah.
if you don't mind, can we do parallel combination in the next class?
What? Why?
If
Why? What happened today? In the last class we have done this also. Means I have review earlier. Then
okay, yeah, you can continue, sir.
So what is the problem? You can tell me the problem. After that we will
Nothing, sir.
discuss.
I'm just facing issues with my laptop, sir. That's it.
What you are facing?
Issues with my laptop.
What kind of
No,
issues?
sir. You can continue. Now it's fine. I'll tell you if there's a problem.
If you are getting bored, then you can tell me.
No, it's not boring, sir. There's some issues with my laptop. That's it.
Okay. So parallel combination is like this.
Yes, sir.
And a battery is connected like this. This is the resistance R1,
R2 and
R2,
R3.
R3. So if you will take the point, suppose here is a point A and here is a point B, and this is the V, then VA minus VV is equal to V.
Yes, sir.
Potential difference between this terminal and this terminal. This point here also the potential is VA because there is no resistance in the path. Here also the potential is VV. So you can see here also VA, here also VA, here also VA, VA, here also VV.
Yes, sir.
Here also VA, here also VV. Why this thing is happening? Because there is no resistances in the path. But here to here, when you will move, you will get, if you want to calculate the potential difference or the voltage across V1, so how you will write VA minus VB?
Yes, sir.
Potential difference across two, VA minus VB again.
Yes, sir.
Potential difference across resistance 3, VA minus VB.
VB.
See, all the VA, V1, V2, V3 are same. And this
Yes.
VA minus VB is equal to V.
Yes, sir.
So in parallel combination across each resistor, the potential difference or the voltage is same.
Same.
But in the series combination, the current across each resistance, or you can say the current flowing in each resistor is same.
Yes, sir. So just a minute, draw the diagram.
If you are facing much problem, then you can leave. We will.
No, sir. It's fine. It's actually fine.
We can increase the time in the next class.
No, it's
No
fine.
problem.
Actually, it's fine now. No problem.
Okay.
Yes, sir. You can continue, sir.
Okay. So okay. What I am doing, I am just making an equivalent circuit of this. Instead of all these three resistances, I am just taking a one resistance, and this resistance I am connecting with the same battery of voltage V. This is R equivalent, and I current is flowing like this. And see here the distribution of current. Now we will see, from here the current I will flow. Here also the current will same, as the wire is same, but current will change here.
Yes, sir.
Here I1 current will go, here I2 will go,
And
here
I3 will go.
I2 will go, and here I3, here I1 will go. Means in this resistance I1 is flowing, I2 and I3. So you can write I is equal to I1 plus I2 plus I3.
Yes, sir.
I is equal to
I1 plus I2
plus I2 plus I3 you can write. And now see here, from here you can write I is equal to V divided by R equivalent from this circuit.
Yes, yes, sir.
So I is equal to V divided by R equivalent. Now see, I1 is equal to V1 divided by R1. What is the value of V1? V1 is V.
Yes. V2 is
V divided. Yeah, V2 is also V. So we can write this like this. Like this we can write. Cancel V from all the sides, or you can do one more thing. Take the common V. You will get 1 upon R1, 1 upon R2, 1 upon R3, and now V gone. We have equivalent resistance as in parallel combination, 1 by R1 plus 1 by R2 plus 1 by R3.
Yes, sir.
So this is the thing, and now we will calculate some that things. Means we will calculate the total voltage first.
Okay.
V suffix T. Total voltage is V. And second part, we will calculate voltage across each resistance. Voltage across each resistor. When you will calculate, that is V1 equal to V2, you will get. V3 is equal to V, you will get. If you want to find the total current, then you will write I is the total current, na?
Yes, sir.
Same thing I am doing again and again. I is equal to, what you will do? V divided by R equivalent.
R equivalent, sir.
And if you want to find I1, then you will write V1 divided by R1. But V1 is V and R1 is R1. So for I2, you can write V divided by R2 For I3, you can write V divided by R3. So
Yes,
this
sir.
will be the fourth part, current through each resistor. Current through each resistor. I am doing same thing again and again. I am just applying the formula. We know in parallel combination the voltage is same. That is why I have written V.
Yes, sir.
Now what is left? Power left.
Power.
So if you want to calculate P1 means power lost in the resistance 1, you will write I1 square by R1 into R1, or you can write V1 square by R1, but V1 is equal to V, so you will write V square by R1. So P1 is equal to V square by R1. P2, what is P2, Harsh?
V square by R2.
P3,
V square by R3.
total power,
P1
P1
plus
plus
P2 plus P2 plus P3.
P3. Now V square take common, then you will get 1 upon R1 plus 1 upon R2 plus 1 upon R3. And what is this? This is equivalent resistance of
Equivalent
parallel
power,
combination.
sir. Yes, sir.
So V square by R equivalent, you can use this formula also. Note it down.
Just a minute, sir.
Okay, just I am zooming it out. Okay, from here now?
Yes, sir. Can you scroll down? I'm on the last part, sir.
You are on the last part. Okay, this part now?
Yes, sir.
Okay. So I will take 10 more minutes. Okay? Because that day I have left the class earlier and we have to complete the syllabus also on time. Okay,
Yes, sir. Done, sir.
after this I will just solve one question, give you one question only, and that too very easy.
Yes, sir.
Very easy thing, yeah. Now resistances are connected like this. Okay, I can just change this. Harsh, are you revising your notes or not?
Yes, sir. Yes, sir.
I will take your viva in the next class.
Okay, sir.
I will ask basic things.
Okay, sir.
So question is, two resistances are connected like this. This is the parallel combination, and a battery or cell you can say is connected of 100 volt, and this resistance is 5 ohm, this resistance is 10 ohm, and you have to calculate number one R equivalent. Second, you have
Sir,
to
we have to calculate
calculate.
the same thing as last time,
Yeah,
right?
all the things are same. So you have to calculate total voltage
Okay.
and voltage across all resistor. All means two resistors we have, all resistors. Same things are repeating. Third part, you have to calculate total current and current across all resistor. Total current and current through all resistors, or instead of all you can write both resistor, it will be better, na? Both resistors. Both. And fourth is power. Power dissipated
Yes, sir. Power.
across each resistor and total power. Dissipated. So Harsh, solve this question, and I am just giving the 2 minutes for solving this because
Yes,
I
sir.
do not.
I'm solving the last part, sir. The fourth one. I
Very
have
good, yeah.
done.
Very nice. And you can check your answer also.
Yes, sir.
I will solve the question. And this is R1. I'm supposing this is R2. And as the circuit is like this, so you can say that the current I is flowing here, and I1 is going there, and I2 is coming here. Now all resting. Here is the voltage V1, and here is the voltage V2. So Harsh, I am starting, okay? Completed, Harsh?
Just I'm done. So fourth one.
Okay. You can solve, and after that I will solve, and you can check your answer.
Yes, sir. Done, sir.
Okay, fine. Now check your answer. Okay. We have two resistances. Answer one.
Yeah. R equivalent is 1 by R plus 1 by R2.
Yeah. 1 by R equivalent is equal to 1 by R1
1 by
plus
R1 plus
1
1
by
by
R2. This will become 1 by 5 plus
1 by 5 plus
10.
1 by 10 is equal
So
to 2
10
by
is
10.
the answer.
Yeah.
Okay. 2 plus 1.
2 plus
This is
1. 3 by 10.
3 by 10. So R equivalent you will get 10 by 3 ohm. Second answer is they are asking voltage. Total voltage is equal to 100 volt, and V1, V2 and V3 all are same.
Yes,
100
sir.
volt, because this is a parallel combination now, not V3.
Yes, sir.
V1
Yes, sir.
and V1 and V2 are same.
Same. It will be 100.
Yeah, if V3 is
Volt.
there, then V3 will be also 100 volt.
Yes,
That
sir.
is 100 volt. They are asking the total current. So how you will calculate the total current? V total divided
V by
by
R equivalent,
R
sir.
equivalent. So what is V
It will be
total is
100 by
100.
10 by
R,
3.
yeah, this is 10, and by 3 this will become
It will be 100
into,
into 3 by 10.
so this will become
It will
30
be
amp,
300, sir.
not
Yeah,
300,
sir, 30 amp.
30 ampere.
30, yeah, sorry. Yeah, I
And
forgot.
for I1 you will write V1 divided by R1, but V1 is equal
Yes,
to
sir.
100 and R1 is 5. You will get 20 ampere.
5, sir. 20 amperes, sir.
V2 by R2. V2 is 100 again. This is 10. You will get 10 ampere. You can check also. I is equal to
Yes.
I1 plus I2, and we have calculated I as 30, I1 as 20. This is 10. So this is 30 and 30. So means this all the things are correct. So now power dissipated.
Yes,
Fourth part. Power dissipated. So P1 is equal to V square divided by R1. V square means 100 square. R1 is 5. So I can write this 100 into 100 divided by 5. So this will become 2000.
Yes, sir.
What? 5. You will cancel it out. 20. P2.
Yeah,
Same
it will
formula.
be 2000. Yes. Yes, sir.
This will be 100
Yes, sir.
square by 10. So this will become 1000 watt. Total power you want to calculate, you will write
3000
P1
watts, sir.
plus
Plus
P2,
P2.
2000 plus 1000, this will become 3000 watt. And I have already told you one formula.
Yes, sir.
Total power is equal to V square divided by R equivalent. V square is 100 square. R equivalent is 10 divided by 3. So this will be 100 into 100 divided by 10 multiplied by 3. You will get 3000
Yes, sir. Done,
watt.
sir.
So this is the answer, Harsh.
Done,
See,
sir. Already solved it.
easy questions now.
Yes, sir.
In the next class, I will take one good question and we will solve
Okay.
it. Okay.
Okay,
Okay,
sir.
Harsh. Please revise your notes, and if you have any doubt regarding this, you can ask me right now.
No, sir.